Hello dear students, I again welcome you in this class. This is lecture number 4 of acid, base and salt. So let's move ahead on the next slide and let's talk about the remaining concepts of this chapter. Okay students, so here I am. Now after understanding about acid and bases and their reactions with metals, non-metals, and we have also seen indicators. Now I will be telling you some salt which is to be studied. Okay, so we will talk about some salts here. So we all know that what is a salt and how is it formed, because I have told you this many times. Now to form a salt, the simple reaction is neutralization reaction. Neutralization reaction. So what is the neutralization reaction? We all know that whenever acid and base react, they will form salt and water. So this is the salt which we are talking about. Generally, this salt is neutral. Okay, but guys, there are many salts which are not neutral as well. So why is those salt are not neutral? So I will teach you about this on the upcoming slide. So let's move ahead on the next slide. Okay students, so guys, we all know that salt is a result of the reaction between acid and base. Okay, so if strong acid reacts with strong base, if strong acid react with strong base, then guys, the salt produced in this case will be a neutral salt, neutral salt, and water will also be formed in this reaction. So this is a first type of reaction. So if I give you an example of this, so let me write HCl reacting with sodium hydroxide, and it is forming an ACl plus water. Okay, but guys, if strong acid, this strong acid react with weak base, weak base, so in this case the salt which will be formed will be acidic salt, will be what? Acidic salt, and water will also be formed in this reaction. So what I told you, when strong acid react with strong base, then neutral salt is formed. But when strong acid react with weak base, so because this acid is strong here and base is weak, that's why the produced salt will be acidic salt. It would be acidic in nature, because you can see that acid is stronger here. Okay, now guys, if I give you an example of this, so you can write H2SO4, which is sulfuric acid, and when this sulfuric acid reacts with MgOH whole twice, this is magnesium hydroxide, magnesium hydroxide. Okay, so when there is a reaction between sulfuric acid and magnesium hydroxide, then because This is strong acid and this is weak base. This is what? Strong acid and this is weak base. When I taught you about acidity, then I told you that to get relief in acidity, we consume this magnesium hydroxide because this is a mild base and it neutralizes the effect of HCl released in our stomach. So we get an instant relief. Okay, so guys, this is a weak base and when this react with H2SO4 which is a strong acid, then it will form MgSO4 which is what? Magnesium sulfate. Okay, and water is also formed. So this is magnesium sulfate. So guys, this is the example of the reaction between strong acid and weak base, and in this case the salt which is formed is acidic salt. So magnesium sulfate is acidic in nature. Okay, so I hope guys these two reactions are clear to you. What has we seen here? We have seen that when there is a reaction between strong acid and strong base, then neutral salt will be produced. But if strong acid reacts with weak base, so in this case the salt which is formed is acidic salt. So after understanding this, let's move on to the next slide and let's try to understand one more reaction about the acid and base so that a concept will get more clear. So let's move ahead on the next slide. Okay students, so here we are. Now we have seen the reaction between strong acid and strong base, and then we saw strong acid and weak base reaction. Now we will see the reaction between weak acid and strong base. Strong base. So in this case, what do you think? The salt which will be formed, what should be the nature of that salt? So I hope most of the students have reached to the conclusion that the salt in this situation will be basic salt. Why? Because you can see that the base in this case is strong. Okay, so this is an example of basic salt. Plus water will also be produced. Now guys, to give you an example on this, let me write a reaction between carbonic acid H2CO3. This is carbonic acid. Carbonic acid. And when this carbonic acid react with this strong base, let's suppose I'm taking KOH, that is potassium hydroxide. Potassium hydroxide. And this is an example of strong base. So when the reaction is taking place between these two, it will produce K2CO3 which is a salt, plus water will also be produced. Okay, so I hope guys this thing is clear to you, and let me tell you the name of this K2CO3. First of all we will write this K2CO3 little bit close, K2CO3, and this is potassium carbonate. Potassium carbonate. Okay, so I hope guys these three reactions are clear to you. this is first reaction between strong acid and strong base. The second reaction between strong acid and weak base, acetic salt is produced. And the last reaction where weak acid react with strong base and basic salt is produced. So students, if these three reactions are clear to you, so can we move ahead? Of course sir, you can move ahead. So let's see what is on the next slide. So let's move on to the next slide. Here we are guys. Here we will discuss about some salt, and we will start with a very famous salt, that is a common salt. Okay, so students, first of all let me take you to this slide, and here some salts are written. So these are the salt which is going to be studied in this lecture. So the first salt is common salt, and the formula of this common salt is NaCl. Is what? NaCl, and it is sodium chloride. Now what is the formula for bleaching powder? So this is another type of salt, and formula for bleaching powder is CaOCl2, which is calcium oxychloride. Okay, now on third number, baking soda. It is also to be studied. So the formula for the chemical formula for baking soda is NaHCO3, and its full name is sodium bicarbonate. And the salt on number 4 is washing soda. And washing soda, if I write down the formula for this washing soda, then it is an A2CO3 dot 10H2O. It is also known as sodium carbonate decahydrate. So basically guys, you can see here 10H2O is written. So that's why we have also added sodium carbonate and decahydrate, because 10H2O is also present, and this is known as washing soda. Okay, now guys, let's talk about the very important salt, and that is plaster of Paris. In short, we call it POP. Okay, now what is the formula of this POP? So the formula is here, calcium sulfate dot hemihydrate. You can see that half molecule of water is present in this calcium sulfate, or the POP. That's why it is known as calcium sulfate hemihydrate. Okay, so this is just a basic introduction about the salt which is going to be discussed. So first of all, we will again come to our current slide, and we will see the common salt, and we will start with sodium chloride. So student, sodium chloride is very basic salt. So we all know that what is a common salt. Common salt is basically NaCl or sodium chloride. Okay, now what will happen in chlor-alkali process? To understand this chlor-alkali process, let's move on to the next slide, and let's talk about some of the theoretical points related to this chlor-alkali process. So here we are on this slide. We will talk about some theoretical points related to this chlor-alkali process. So when electricity is passed through an aqueous solution of sodium chloride, or the aqueous solution of sodium chloride can also be known as brine. So it decomposes to form sodium hydroxide. Okay guys.
So what will happen when electricity is passed through an aqueous solution of sodium chloride? So it will decompose to form sodium hydroxide, and this process is known as chlor-alkali process. This process is known as chlor-alkali process. Now, this process is taken place by electrolysis of aqueous sodium chloride. So this aqueous sodium chloride is basically can be known as brine. The solution of this aqueous sodium chloride, it means the solution of sodium chloride is basically brine. So what will happen if you pass electricity through it? So it will decompose and it will form sodium hydroxide. Now let's move on to the next slide and let's see the equation, the reaction. So this is the reaction, and here you can see that sodium hydroxide is formed, chlorine is formed, and hydrogen gas is formed. These three are the product of this process. So when electricity is passed through an aqueous solution of sodium chloride, chlorine gas is given off at the anode. This is very important, that chlorine gas will be released at anode and hydrogen gas will be released as cathode. Okay, and sodium hydroxide solution will be formed near the cathode. It will be formed near the cathode. Okay, so this is the balance equation for this chlor-alkali process, and you can see three products are formed in this reaction. So I hope guys these things are clear to you. Now let's move on to the next slide and let's talk about one by one all these three products. Okay.
Okay students, so here I am. Now I will be telling you the uses of the product formed in the chlor-alkali process. So students, you can see that the first product of the chlor-alkali process is hydrogen. Okay, now this hydrogen has various uses and it was available at cathode in the pure chlor-alkali process. Now let me tell you what are the uses of this hydrogen. So guys, if you react this hydrogen with nitrogen gas, then ammonia is formed. This is NH3 and this is what? This is ammonia, and this ammonia will be used as fertilizer. Okay, and guys, this hydrogen is very explosive gas. Okay, this is very much explosive, so it can be used as fuel, and this is also used to convert oil into the fat. Okay, this will use to the convert oil into the fat, and this particular application will be taught in the upcoming chapter when I will be teaching you carbon and its compound. Then I will be teaching about this conversion of oil to fat. Now guys, let's talk about the other applications of chlorine gas which we have got at anode. So what are the applications? So this chlorine gas is used in water treatment. This is used in water treatment to kill the germs. Okay, and guys, this is also used in refrigerator as CFC. This CFC is chlorofluorocarbon. This is chlorofluorocarbon, and guys, this is very dangerous chemical. It is responsible for the hole in ozone layer, and because of the corrosion of that ozone layer, the UV rays is reaching to our earth and it is damaging our skin. So this is responsible for the hole in the ozone layer. I hope guys the application of this chlorine gas is understood by you. Now guys, it is also used as disinfectants. Disinfectants. Okay. So guys, now after understanding this, let's talk about sodium hydroxide. So sodium hydroxide can be used to degreasing metal. Degreasing metal. So to remove the grease on the metals, we can use this sodium hydroxide. It will remove the grease on the metal. And as we all know that sodium hydroxide or the main use of sodium hydroxide is in soap and detergent. Soap and detergent. It is very widely used in soap and detergent. Now guys, this is also used in paper making. Paper making. Okay, so these are the uses of the elements or the compounds which are formed by the chlor-alkali process. Okay, I hope guys this basic thing is clear to you. Now after understanding this, let's move on to the next slide and let's talk about the other uses of these things. Okay students, so here we are. Now guys, we have seen that hydrogen and chlorine was formed in the chlor-alkali process. So if you react further, hydrogen and chlorine, if they react with each other, then they will form HCl, which is hydrochloric acid. And this HCl has also various uses. So hydrochloric acid, and it has various uses. So the first use of this is to make ammonium chloride. Ammonium chloride. Okay, so how this ammonium chloride is formed? So guys, when I react the HCl with NH3, then what will happen? It will form an H4Cl. Okay, this is the reaction to make ammonium chloride. When ammonia reacts with HCl, it forms an NH4Cl, which is ammonium chloride. Now the other application of this hydrogen gas, or you can say HCl, hydrochloric acid, the other application of this cleaning steel. Cleaning steel. It is used to clean steel. Now guys, this is also used in medicine. Medicine. And I also told you that this HCl is released in our stomach. Okay. So these are the applications of the hydrochloric acid. Now guys, you might be surprised that NaCl, which is our common salt, we have produced lots of things. Hydrogen, chlorine gas, and AOH, and then HCl. Okay. So now guys, I will tell you about bleach. So what is a bleach? When the NaOH, which is sodium hydroxide, reacts with Cl2, reacts with chlorine gas, then it will form bleach. And this bleach is used to clean, or you can say to the cleaning of our house. Okay, and you can bleach our clothes, you can bleach household. Okay, so this is the example, or you can say these are the subproduct of the chlor-alkali process. So I hope guys these things are clear to you. Now after understanding these things, let's move ahead and let's talk about the other things. So students, here we see
some examples. So let's talk about these examples first.
A milkman adds a very small amount of baking soda to fresh milk. Why does he shift the pH of the fresh milk from 6 to slightly alkaline? So basically guys, this question says that a milkman adds a very small amount of baking soda. So we all know that baking soda, I will be teaching you about this baking soda later, but for now on you just need to know that this baking soda is basically a base. This is a base. So he is adding a base in the fresh milk so that the pH of the milk will increase, because we know that the pH of bases are higher, or you can say more than 7. So if it adds a base in it, then the pH will become high, or you can say the pH will move from 6 to slightly alkaline. So guys, why it is, or you can say why the milkman is doing this. So guys, milkman is doing this because he wants the milk to be slightly alkaline. Okay, and what if it is slightly alkaline? If it is slightly alkaline, so it may not get sour easily due to the formation of lactic acid in it. We all know that milk has lactic acid. Milk had lactic acid. So if there is an excess of lactic acid, then it will become sour. So that's why he adds some baking soda in the milk, so that it is, it will not get sour easily due to the formation of this lactic acid. Now guys, let's answer this second question. Why does this milk take a long time to set as a curd? So here it is saying that when you mix baking soda or a base inside the milk, then why does it take long time to set as a curd? So the answer of this question is, we all know that the lactic acid which is formed in the milk, it has to first neutralize the alkali present in it, because we have mixed the the baking soda in it, and this is a base. So first of all, the milk has to neutralize this base, and then it will form lactic acid. That's why it will take long time to set, because first it will have to neutralize the base which we have mixed in it, and then it will turn into the curd. Okay, so I hope guys this example is clear to you. Now let's move ahead, and I hope guys whatever we have done here in this lecture have been understood by you. So thank you so much guys, and we will meet in the next lecture. So bye bye guys.